Hi everyone, welcome back to those who have been with us since the start of the first session. And for the rest who are joining us, just welcome. I'm Chris. I am a recruiter with GovTech, and today I will be your host for this session. What we're going to do today is we're going to have a few government deep dive sessions, and the sessions will feature agencies within the Singapore government which operate within the tech domain. Now, we're having two sessions that's going on right now. You are logged into the data science one. If you're looking for the other section, maybe you might have to click a different link. Yep. Okay, so before we start, for those who have just joined us, we're going to go through a few house rules as well. Firstly, we'd like to inform you that we are recording these sessions, so just keep that in mind. And we have three house rules today. We know that you have many questions. Our speakers are going to share with you a lot of amazing stuff, and we'd like to hear from you as well. So for all the questions, right, please put them within the Q&A panel itself. We know it can be quite confusing with the chat function, but the chat function will not get you the right answers from the right people. If you put it in the Q&A panel, we will get our colleagues to look at the questions and to give you the best answers possible. When asking questions as well, right, do put the name of the agency before the question. This will allow us to know who exactly to look for, and we will get the person to actually look at your question and give you answers that are quite relevant as well. For example, if you want to ask a question about GovTech, for example, GovTech, where is your office? A GovTech staff, maybe me, I might come in and say, oh, okay, we work here or we work elsewhere. If you want an IMDA colleague to actually answer a question, you can put IMDA, where is your office? And they will get back to you. Now, we're all here to learn, we're all here to help each other. We ask that everyone be courteous and considerate to both the speakers and your fellow attendees as well. We don't have the whole evening, we kind of have an hour or so. As such, we might not be able to answer all the questions that you have today. But fret not, what we're going to do is we're going to move the questions over to the Slack channel, and we'll take it from there and continue to engage you as well. For those who are interested in sharing your CVs or your LinkedIn profiles, please have a look at the QR code there, and we're more than happy to get to know you better and to understand your personal aspirations as well. Okay, now with that out of the way, let's start with the various speakers that we've invited today. First up, we have colleagues from GovTech's Data Science Division. We have Bill, who is with the Video Analytics team. And we have Joy. Joy is a data scientist who's forward deployed to a partner, Enterprise Singapore. So without further ado, let's invite Bill and Joy.
Hi, good morning, afternoon, evening to everyone. My name is Bill, and I'm an Associate Computational Scientist with the Video Analytics team within Data Science and AI Division, or DSAID in GovTech. We're here to share more about what we do at DSAID, along with my colleague Joy, who is also, her video is also on, a quantitative analyst with the quantitative strategy team. I'll start this presentation by introducing about DSAID and my experience here before passing the time on to Joy, who will elaborate more about her thoughts about the quantitative strategy team. At Data Science and AI Division, we are a relatively young and growing team. The list of teams that we have at DSAID is listed in the top right-hand corner, and definitely feel free to contact us about any roles related to data science or AI that you have an interest in. What DSAID does broadly is to promote and enable the use of AI and data science across the public sector to achieve better outcomes for citizens and government. To do that, we work on agency projects to advise and provide consultancy for data science projects. We also incubate specific AI solutions that have meaning and impact, and when appropriate, do so through partnerships with private sector and academia. As you may know, data science and AI applications are not possible without the underlying infrastructure to run models, to run ETL pipelines. So we develop, maintain, and own core products and platforms that allow ourselves and the public sector as a whole to rapidly prototype and scale data science use cases. Last but not least, we build data science and AI capabilities in the broader public sector through different levels of engagement, guides, trainings, workshops, and forward deployed teams as well. Now a bit about myself. I did my undergrad and master's in UChicago and MIT respectively. Before coming back to Singapore, I worked in Bay Area companies ranging from 80 to 800 people. I also had the opportunity to do computer vision and AI research and publish a few papers in my time in the US as well. So my role in GovTech, broadly, I do three things. I manage, write, and design infrastructure for a cloud-native computer vision platform that we are building to enable diverse use cases that my team supports. So the agencies can use computer vision to automate a lot of the manual work that they do. I also work on refining and building new computer vision models, and also on architecting systems and products that are impactful and practical. One such product that I had a chance to work on is the people counting system behind Save This Parks, which is the NParks website that allows visitors to see how crowded parks are. We managed to spin up a prototype within 2 weeks, and now we managed to scale to parks cameras nationwide so that NParks officers don't have to physically go down to parks to do crowd estimation. Now, the following slides may attempt to give you an idea about the types of problems and ideas that we grapple with in my team. With video analytics, we deal with large volumes of video and image data. To handle this at low latencies and high availability, we work daily with frameworks and libraries like GStreamer and WebRTC. We also have to constantly find and revise the appropriate abstraction for the kind of AI workloads that our systems handle. AI models move very quickly. Frameworks like TensorFlow and PyTorch improve, and in some cases go the other direction and change. And the hardware that we deploy to depends on the application that we face. So we might need to deploy to edge devices, to cloud GPU systems, or to even mobile phones. So how can we manage all this complexity? Choose technology that allows us to meet 80 or 90% of our use cases is a question that we face. Similarly, for the image and video data that we ingest and the agency backends that we integrate to, we also have to rationalize and optimize. Broader questions that we ask ourselves is how can we experiment and implement technology to really allow us to scale super linearly? It's not just about the technological tool per se. Cloud native tools, for example, may allow engineers to have a simpler interface to relate infrastructure with application requirements. But to use them effectively, we need buy-in from engineers. And we also need to build tools around these technologies. When we have AI as a hammer, everyone is tempted to see everything as a nail and try and solve everything with AI. But part of what we see our role at GovTech is to really guide and influence our partners across the public sector to effectively and responsibly use computer vision and AI. Lastly, my team and I do quite a lot of self-examination to really understand how we can constantly improve our team culture so that everyone in the team is engaged, empowered, and also comfortable with the work and the day-to-day culture. In the COVID period, we still try to do things like regular checkups over video conferences, even eating breakfast over video conference. And today, some of us who met up also even proposed playing Among Us as a video game. So feel free to hit me up on the Tech Forum Slack or the Zoom Q&A if you have any questions. Otherwise, I will happily pass my time on to Joy. Joy, over to you.
Thanks, Bill. Hi, everyone. My name is Joy, and I'm a data scientist with a GovTech quantitative strategy team. I'm excited to be sharing with you today how my team contributes to public sector transformation through data science. To start off, a really quick introduction of myself. I graduated from the University of Toronto in 2015 before starting my first role as a data science consultant with Ernst & Young Singapore. During this time, I did quite a number of data science projects with various government agencies, and I think this is when it really laid the foundation for me for my interest in public sector work. So between my current role and my IT consultancy role, I took my master's in intelligence system while working as a part-time research assistant with Lee Kuan Yew School of Public Policy, building for them a text mining tool to understand longitudinal social perception changes. So what do I do in GovTech? I think to answer that question, it's helpful to first get to know a bit more about my home team, quantitative strategy team. So within quantitative strategy team, there's actually two sub-teams. Our central team does more of consultancy type of projects for public agencies. And the scope of work tends to be surrounding the use of data for answering strategic policy questions. And then you have the forward deployment team. This is a team that sends little squads of data scientists to be embedded within public agencies to help them build up their data science capabilities. And this is a team that I'm a part of. Currently, I am forward deployed to Enterprise Singapore, an economic agency, together with two other colleagues. So now, what exactly is it that we do to build data science capabilities into the host agency's DNA? Bill, next slide, please. So today's session is too short for me to go into all the exciting details, but feel free to scan the QR code on my slide right now to read up all about it on my Medium article. But to give a really quick summary of the type of work that we do, I think I can summarize it into generally four broad categories. As data scientists, our first priority is, of course, to implement data science models. Generally, our models seek to do one of two things. The first is to support the agency in understanding the needs of SMEs and startups in Singapore, such that there are more targeted policies, levers, and assistance that can be offered to them to help them grow both locally and internationally. So an example of our work in this area is a recently concluded text analytics project where we helped our policy officers better understand the inquiries that our local companies are asking in our customer-facing help centers. And this project has been especially timely in view of the disruptions to businesses brought about by COVID-19. The second type of projects that we tend to do has a stronger focus on operational excellence. Here we're talking about how we can use data to support transformations and enhancements of business processes. So for example, enhancing due diligence of our grant evaluations is a key part of our work plan for 2020. The second area or second way in which we uplift the agency's data science capabilities is really about how we can equip the agency with infra and platforms to allow data science to be done at scale, and not just by us, but also by power users that we have identified and groomed along the way at the agency. And of course, as part of this process, we will also need to look into how we can align our data science setup with industry and agency systems and standards, especially in the area of security. An example of our work in this area would be some of the migration work that we're currently doing for our on-prem implementations to go onto the government cloud. The third area of capability development concerns data. So as data scientists, we know that it is very important for us to have good access to quality data. However, for many agencies, they may still be in their early days in terms of their understandings around data architecture and management. So this is where we hope to assert technical leadership in transforming how data is being captured, managed, and democratized at the agency to support secure and reliable data use. And finally, I think it's impossible for us to drive digital transformation at the agency if we're only talking about a small team of 3 data scientists. And at DSA ID, I think we are acutely cognizant that of the importance of having people journeying with us. And we do so in many ways, be it in the form of offering trainings and programs for our partners, or by co-creating projects together with our agency officers. So one of the questions that you may ask at this point is then, how is it possible to find somebody who is so well versed in all these different areas of work that we do? Well, I think while the FDT is the face of DSA ID at the agency, we actually rely very heavily on the larger brain within our central teams. So just now I spoke about our migration work from on-prem implementations to GCC, and Bill has been advising us on how we can design our CI/CD pipeline in a way that's efficient and secure. And also in the area of capability development, instead of having to roll out our own bespoke kind of materials and training guides for our agency officers, we also have a central unit that is designed to come up with very helpful guides to be used at the agency level, such that the FDT is more on the implementation end rather than the braining side of things. Yeah, and finally, even for the data piece, we have a very strong data engineering team and a few experts in the area of data architecture. So we've been reaching back to our home teams in a sense to really find out about the best practices in these areas. Yeah. So all in all, I think my experience in FDT has been super exciting, precisely because of how dynamic the work is. I like the fact that we're able to have experience in all these different areas while staying focused on data science delivery. And also it's been a great experience working alongside brilliant minds in different aspects of tech as well, to do tech for public good together. It's especially heartening for me when I see my host agency grow in its appreciation, adoption of data science and how they how they are transforming to deliver more for Singapore and Singaporeans. So yeah, that's a lightning round of what Bill and I do at DSAID. I'm sure many of you will continue to have other questions for us. Feel free to stay engaged with us through the event Slack channel or read up more about DSAID through the microsite that is owned by our division. So thank you very much.
All right, thank you so much for sharing, Bill and Joy. So I work with the data science team on a day-to-day basis, and they are very bright people. Bright in two ways, very smart, that's one. Bright also, they're always smiling. Like you can see Joy and Bill, they're just smiling and smirking at the camera the entire time. So thank you so much for sharing with us. Now, next up, we are going to invite our speaker from A-Star, and that'll be Dr. Cheston Tan. Now, Dr. Tan is a Deputy Executive Director for the A-Star Initiative for AI and Analytics. Dr. Tan, please.
Sure. Thanks, Chris. Hi, everyone. My name is Cheston, and today I'd like to share with you more about A-Star, Agency for Science, Technology and Research. So I will not talk too much about myself, but just to say that I wear multiple hats. One is as a management head, and one also is that I run my own research group. But today I'll give you an overview of A-Star, and not specific to my own research. So the first thing I would say is that A-Star is a government-funded, government-linked R&D organization. And the title of my talk was From Ideas to Impact, because I think A-Star is somewhat unique in this respect, whereby it does research from the very basic level all the way to deployment. And if you're familiar with the TRL scale, technology readiness level, we do, let's say, TRL 2 all the way to 8. And our mission is to advance science and develop innovative technology to further economic growth and improve lives. So I know this is a mouthful, but over the next couple of minutes, I'll share with you some concrete examples in which we try to achieve impact both economically, but also in the society. And our vision is to be a global leader in science, technology, and open innovation. So A-Star is a pretty big organization. It's about 5,000 staff, including 4,000 researchers, both engineers and scientists, spanning across a wide range of research areas. As you can see here, chemicals, electronics, engineering, infocoms, and so on. And of course, today I'll focus on the infocoms and in particular, AI and data science. So our researchers really come from diverse backgrounds. In fact, 40% of our researchers come from 60 different countries, right? And roughly speaking, it's 50-50, those with PhDs and those without. There are other parts of A-Star that support the research, including industry development, talent development, and so on. And I will not say too much about those. For today's audience, of these many research entities within A-Star, the ones in yellow are the ones that are more relevant. So let's start in the middle, the Institute for Infocom Research, or ISCADA, which is where I'm from. So this is an institute with about 500 researchers, of which about 300 of them work in data science AI. The rest of them work in cybersecurity, comms, and so on. The second one I want to point out is IHPC, the Institute for High Performance Computing. This is an institute of about 300 people, and about 100 of them work in AI data science. And on the biomedical side, if that's what you're interested in, there is the Genome Institute of Singapore, as well as the Bioinformatics Institute. So in total, across the whole of A-Star, I would say about 500 plus researchers in AI and data science. I also want to mention briefly that in red, you can see here that A-Star holds some national platforms, including the National Supercomputing Center, as well as the National Robotics R&D Program Office. If A-Star is not so well known to you, it might be because it's not a university. So, the local universities such as NUS and TU, they rank really well every year globally, right? Reaching the top 10 sometimes. So these are some rankings in which A-Star does pretty well in, and I won't go through all in detail, only the one on the upper right. This is a ranking by Reuters last year of the research institutions in the world, and these are for government-funded institutions, right? So others on the list include things like the Max Planck Society, the UK Medical Research Council, CSIRO from Australia, RIKEN from Japan, and so on. And this one ranking which A-Star does pretty well in, right? Number 5 globally out of, I think, 20 organizations. Let me now turn to, I think, 3 areas of impact in which A-Star hopes to move the needle. So this one is about industry or economic impact. As you can see here, some of the headline numbers, more than 1,005 industry projects every year. And these projects catalyze something like $250 million in R&D every single year. And of course, we also have large efforts in commercialization and licensing. Now I want to turn to what is most societal impact. And of course, there's many ways to measure societal impact. But just one proxy measure that I'm using here is just mentions of A-Star's R&D in the Straits Times, which of course is Singapore's national daily with readership of more than 1.2 million readers every day. So on the left here is something from earlier this year. This is where the translation technology from I2R was actually used in the Singapore government, mentioned in Parliament. This is, of course, for the local languages, the 4 national languages. And it turns out that the I2R technology was actually better than many of the commercially available technologies, which is why the government chose to use it. On the right over here, this is the MATAR robot, M-A-T-A-R. This is a joint project again with A-Star and the Singapore Police Force, as well as the Ministry of Home Affairs and HDX. As you can see here, there are several different versions. These 2 versions shown here are the ones from A-Star, and these have been done trial deployments in various events, including, I believe, the NDP last year. Right. So one example from natural language processing, one example from robotics. Of course, there are many others that I don't have time to go through here, including computer vision, data analytics, and so on. On this slide here, these are more about the biomedical related, or rather AI applied to biomedical applications. On the left here, this is something about using computer vision to interpret eye images. And this was done, work done together with the Singapore National Eye Centre. If you're familiar with the research journals, this was published in the New England Journal of Medicine, one of the most prestigious journals, even more prestigious than Nature and Science. This was something that I believe was trialed with local patients, and I believe that the Singapore National Eye Centre will try to deploy this to help Singaporeans quite soon. On the left, this is something that the Bioinformatics Institute in A-Star does. As you might know, Singapore has this goal of producing 30% of Singapore's food by 2030. And due to Singapore's land constraints, of course, this is not going to happen in traditional farming methods. So this one effort from A-Star to help to improve the crop yield, in particular for the vertical farming and urban farming settings. Now, let me turn to COVID-19. Of course, this is the issue of the day. When COVID struck, I think A-Star being a national organization, we turned a lot of efforts towards tackling COVID-19. Of course, on the biomedical side, developing vaccines and tests and so on. I want to mention the AI-related efforts tackling COVID-19. On the left here, this is something that I2R and IHPC did together with Tan Tock Seng Hospital, TTSH, as well as NCID, the National Center for Infectious Disease. And this is already, in fact, in deployment for a couple of months already. So essentially what they're doing is to use computer vision to detect lung infection. And because of the sheer numbers of chest x-rays that the radiologists had to go through, they really didn't have capacity to go through this manually one by one, or rather that the rate at which they went through manually was too slow to detect some of the cases. So what this algorithm does is that it re-ranks the cases such that the more likely ones are surfaced to the radiologists early, so therefore detecting the cases earlier. On the right here, this is a NLP chatbot app that was deployed for the community care facilities. And essentially the idea is to have more timely and accurate information conveyed to the patients. And of course, this was not just in English, but in the home languages of these patients. Let me now turn to impact in the scientific research domain. Of course, A-Star has many research projects. I'm just featuring 4 here. I think these are the more exciting ones to me personally. The one on the upper right here is something that I'm personally involved in. And this is really about next generation AI that deals with humans in a way that they should be dealt with. Like, learn like humans, understand them, and reasons for them in ways that I think current deep learning technologies are not able to right now. This is a large effort involving not just A-Star, but also the local universities. I think this is where A-Star plays a leadership role. Many of these projects are large interinstitutional projects involving the whole local ecosystem. And this is where A-Star, wearing its national hat, likes to lead such projects. On the upper right here, this is learning with less data. And of course, many of us here know that deep learning is very data hungry. And this, again, is a cross-Singapore effort involving universities and A-Star, taking various approaches, including GANs, including knowledge graphs, in order to come up with systems that use less data. Just a brief mention on the other 2 projects. A-Star has several AI chip projects, both from the traditional deep learning approach and also from neuromorphic computing approach. And lastly, on the bottom left here, this is something that, not sure if everyone's familiar with the term, the good old-fashioned AI. So this is a project that tries to hybridize current deep learning technologies together with good old-fashioned AI technologies in order to have a knowledge platform that, again, is able to explain in ways that humans can understand. So I believe this is my last slide here, and I'll let this sit up for a couple of minutes. I just want to say that our talent, as I mentioned, is very international, and we're really taking the best research talent from all over the world. I noticed in the chat Q&A, there was a couple of questions about PhDs. As mentioned, I think about half of our researchers have PhDs, half of them don't. And in practice, I think people's research skills are what matter most. I can tell you, for example, in I2R, we have non-PhDs leading large research departments as well as leading large projects as well. So it's really the capabilities and the skill sets you bring in that really matter. And of course, I'll be happy to connect with anyone who is, I would say, outside the norm. Now, I know in these days, research in AI has changed over the last 10 years. Many of you would know about AlexNet, of course, and Alex Krzyzewski, the guy behind AlexNet, was a master student when he came up with this breakthrough back in 2012. And I was there when Jan LeCun and so on, they sort of launched this revolution. So in fact, Alex Krzyzewski, if I'm not mistaken, didn't go on to a PhD. He's finished on a master's and went on to other things. So I think the research in AI has changed dramatically over the past 10 years, and maybe globally, even in the US, for example, university professors, I would say 99.99% still have PhDs and so on. But the research really has moved on quite dramatically. I know that in large companies, in Google, you can really do cutting edge stuff regardless of academic background. So I'll say personally, as a hiring manager, I'd be more than happy to take on anyone bringing the right skill sets and capabilities. And with that, I think I'll end my presentation and see if any time to take questions. Thank you.
All right, Dr. Tan, thank you so much. So we have a few questions posted, and I think we're going to just put forth one to start. So we have a question asking, what platforms does your team use to enable collaboration across the organization and to monitor your data models?
Yeah, I'll say A-Star is a very large organization in which the units are kind of semi-autonomous. So there's no single standardized platform for any of these. Depending on your team, depending on your institute, there'll be various platforms. People use Slack, WhatsApp, all sorts of things. Yeah, so there's really no standard. Again, because our customers, whether in the government or industry, they have different requirements. So therefore, each of the teams working on different projects have to kind of adhere to the customers also. Yeah, thanks.
All right, and we have one more question, slightly unorthodox, I would say.
Okay.
Sean would like to ask, what keeps you up at night?
Oh, giving talks at 2 a.m. That's what keeps me up. But no, really. Well, I mean, it's a good question. I have to say, in my current situation, it's because I'm a dad to a 3-year-old and an 8-month-old. So one of them was actually born during COVID, during circuit breaker. So what keeps me up at night is my normal work. I honestly speaking, I take care of my kids until like 10 p.m., put them to bed, and 10 p.m. is when I start working. And that's what keeps me up at night. Thanks.
All right, thank you so much. Doctor by day, dad by night. Okay, thank you so much, Dr. Cheston Tan. Let's invite Chris over to take.
All right, thank you. Hi, everyone. Very good evening, morning, and afternoon. I'm Chris from IMDA, and thank you very much for staying all the way to the last session. And I'm really happy to be here today to share more about the work that we are doing in IMDA on AI and data. And firstly, I would like to share a short introduction. So IMDA is the agency that develops and regulates the media and infocom sectors in Singapore. And a little bit about myself. I used to be an AI researcher many years back, doing intelligence software agents as well as reinforcement learning. And then following which I move on to different places, including the private sectors. And right now I'm with IMDA, leading the AI and data team. And the main things that we are doing is largely working with industries to ensure that we can actually translate AI technologies into deployable products in the enterprises. So that's the main reason why I'm sharing today about AI adoption and how we are actually doing accelerating the AI adoption. So moving next, before going into the details of what we are doing in IMDA, I would like to take a step back and talk about the broad landscape of the rise of digital economy. So first of all, I'm very sure most of us, if not all of us, would have experienced changes in our lifestyles as a result of the rise of the digital economy. I'm pretty sure that many of us will have changed the way that we consume media, we interact with our friends, and also purchase things online. And it's precisely because of this change in behaviors that studies have shown that the digital economy is actually one of the very important economic drivers, right? Not just globally, but also in Singapore. But if you look at it, besides being an economic drivers, the digital economy is also a very important impetus in terms of leading to AI development and adoption across different sectors. As businesses and enterprises embark on their digital transformation journeys, we actually see that a lot of new digital service touchpoints are created and the processes digitized. And this basically leads to the ability to collect a lot of data. And as we all know, data is the key ingredient for us to train and develop new AI models. And it's actually because of this trend that studies have also shown that AI by itself is also going to be a very important economic drivers. And in fact, if I were to cite the EDBI studies that was conducted very recently, AI is actually projected to add 1 trillion to Southeast Asia GDP by year 2030. And for Singapore alone, we are looking at an 80% uplift by 2030. So if I were to take a closer look at what's going on in Singapore, I think we can certainly see a lot of growth opportunities for us to do AI development and translation. The reason is because if you look at some of these statistics and studies, 70% of the SME have not adopted data analytics. Of course, not all of them are suitable to use data analytics, but we see that there's actually a lot of potentials for us to engage them and to help them in different ways. And again, if I were to cite the EDBI studies on AI adoptions, more than 50% of the respondents in the studies are still at early stage of piloting AI, and only 7% have reached the end-to-end implementations. So we see a huge potential for us to work with the industries to see how we can actually help them accelerate this whole process. So in IMDA, we want to look at adoption from a holistic angle. Why do I say that? The main reason is because we recognize that in order for an industry or a company to adopt AI, we have to look beyond technology maturities. We have to understand what the business needs. And that's because there are a lot of other factors that can actually lead to sustainable adoption of artificial intelligence, and of course, broadly from technology adoption point of view. So from that angle, we are going to address this translation process largely based on 2 dimensions. From first, of course, looking at the business gap, whether can we create new business use cases jointly with the industries so that it's actually viable from a business standpoint. And of course, from a technology gap, how can we help them? How can we understand the kind of resources that they lack from a technical standpoint to deliver high performance enterprise grade AI products? It could be data, it could be other kind of algorithm issues. So that's the kind of angles that we're looking at. And I'm going to share more about our approach next. So in IMDA, the team that I'm leading, we are actually looking at it from a BizTech model, right, to drive AI adoption. And in that, I can start first by looking at the catalyst, which is essentially what I term as the Biz. All right. From the catalyst angles, we are looking at how we can actually proactively work with the industries to develop new business case. This actually entails understanding the nature of their business, what can be done viably so that from a business standpoint is viable, and at the same time analyzing the outcome of deploying some of these new solutions. And in order to achieve high scalability of our translation effort, we also have to do a lot of demand aggregation to understand what could be a common pain point within the sectors or within certain clusters of businesses. Once we have identified some of these common pain points and come up with the business requirement, the next step is basically to translate this requirement into technical specifications. And that's where it leads to the bridge part of this equation. So from bridge actually is technical. And in IMDA, we have an in-house team that does a lot of new AI model development. We also does data acquisition so that because we recognize that both the data and the algorithms are the key ingredient to successfully developing high performance AI models. And in that, we actually also do a lot of supply side aggregation to understand what are the common technology components that are needed by different kinds of supply side vendors. And at the same time, we're also investing in sophisticated techniques and algorithms such as transfer learning so that we want to reduce the cost of domain adaptation eventually. And all this, when it leads to successful deployment, it will allow us to learn from this experience and allow us to develop new use cases as well. So this is how we see the catalyst and the bridge, the beast and the tech interact and consistently generating a potentially multiplier effect. And we can scale using this kind of a model. So in order to illustrate clearer about how we're actually doing it, I would like to cite 2 use cases for tonight, or actually for today. So the first use case basically touched on the use of computer vision for AMR, autonomous mobile robots. So in this particular use case, from a business standpoint, we actually have been engaging different AMR vendors in Singapore. Their core business basically lies in developing these AMRs for various use cases, such as the indoor deployment and other scenarios. So through our interaction with them, we recognize that there could be a potential gap in the way that, in the kind of challenges that they experience when they deploy AMR in indoor scenarios, using LiDAR as a key navigation tools. Some of the examples of the challenge that they encounter includes their AMR entering certain indoor compounds and having to deal with navigating to an elevator when there are passengers coming out of the elevator. So using LiDAR alone, it may not be very effective to detect some of these passengers or people coming out of the lift. At the same time, there could also be difficulties experienced by LiDAR-based AMR to having to avoid some of the hazardous zone bounded by safety cones. So there are different kinds of scenarios and these are actual deployment challenges that are shared with us by the AMR vendors. And some of these vendors, they basically are focusing on developing their AMR robots from from mechanical engineering point of views. And they see that while they acknowledge the need for computer vision, they may not have immediate resources to integrate some of these production-grade computer vision modules into their AMRs. And that's where we come in. That's where we find that there is a common problem faced by a group of supply-side vendors, and we see that there's a potential way that we can help them. So in this case, the engineering team in IMDA basically developed both the computer vision models, and at the same time, we also interact with the AMR vendors to collect data from the deployment scenarios. So these data basically are the background images of the indoor settings that the AMR are being deployed in. And what happened next is that we will also collect the 2D models of the objects that needs to be detected, and we fuse them using various techniques onto the background images. And these images can then be used to train the computer vision models to detect the object in the actual settings. And these models, basically, we can actually avail to these vendors. And depending on the performance, they can actually directly use and integrate these models into their modules, into their AMR directly, or they can actually fine-tune it further with their own company's data. And we do have success stories to share arising from our collaboration with the vendors shown in these slides. The next case study I'd like to share and talk about is about speech applications. So for some of us who have worked on speech before, we know that the key components to successful deployment of speech application lies in both the ASR engine, the technology involved behind the engine, as well as the availability of corpus to train the engine. Now, in Singapore context, we know that we have a pretty peculiar way of uttering English, right? In terms of conversational English, we have our Singlish slang, and at the same time, our accent is different. And also we have many different kind of unique phrases, which probably, if you train the ASR engine on the standard English corpus, it will definitely not understand some of these phrases. So we recognize that Singlish itself is actually a low resource corpus. And we wanted to solve this problem because we see that there's a huge potential that once we solve this problem, there will be a lot of speech application that can be developed, localized speech application that can be developed using this trained engine. It's actually with this idea that the team has started to collect thousands of hours of conversational speech comprising of different demographics of speakers. And we actually avail this corpus to the industries. So there are different modes in which the industry can directly use this corpus, or they can actually use some of the pre-trained model that we have developed using the corpus. So as you can see, with the corpus, the industry can directly fine-tune their existing models, and they can actually add on their other NLP models so that it can be localized for different kind of applications, such as call center transcription or speech-enabled robots. And I'm very happy to share that there are use cases and success stories that are not just experienced by some of the local vendors, but also by some of the global giants that we are working with as well. For example, NVIDIA has created checkpoints of pre-trained models trained with our speech corpus with other data sets. In fact, some of you who are interested can actually access their NEMO toolkit, which is actually a conversational AI toolkit. I believe some of it are available in GitHub. At the same time, Alibaba has also trained their English speech recognition engine with our speech corpus and achieved a higher speech recognition accuracy for Singapore. So these are very useful case studies that we are learning from, and we recognize that again, coming up with a kind of data assets and algorithm assets are very useful and critical for us in our translation effort. So this is my last slide, and I want to end off by saying that in the realm of AI and data, we have really a lot of interesting and impactful problems that we can solve in IMDA, especially when we are the agency taking care of the infocom and media sectors. Moving ahead, we see that there are lots of ecosystem level problems that will come, and they are actually needle moving problems that we want to attack and challenge. And these are some of the examples. Could be the 5G AI problems, where what are the things that we can do with 5G eventually, some of the low latency applications such as computer vision on the edge. And at the same time, aside from opportunities, we also see a lot of new challenges that can arise from some of this AI development, such as deepfake. So it's actually in view of this that the IMDA team is constantly on the lookout for collaborators, experts, and of course, talents like yourself. So if you want to find out more about what we do, feel free to reach out to us. And I really welcome to have a deeper conversation with every one of you. So with that, I would like to end my sharing today, and I'll be willing to take some questions along the way. Thank you.
All right, Chris, thank you so much. So I think you shared a lot right now about all the new and interesting technologies that IMDA work with. Just curious, what's the thought process behind IMDA deciding on what projects to embark on, what kind of technologies to use?
Yeah.
How do you go about this whole process? There's so many things out there, right? How do you decide?
I think that's a very, very good question, Chris. So first of all, as I shared, I think we need to come from this selection coming from two different angles. We have to understand what are the key problems and pain points faced by different industry that we are taking care of. So that means that we have to do demand aggregation. We have to understand what are the common pain points faced by businesses, and we have to actually qualify some of these pain points to ensure that they are real pain points. And when we solve this problem, there are real business return, and this is actually sustainable. So that's actually one of the more difficult part. Then from the supply side, because we cannot be solving individual enterprise problem one by one, because that actually is not scalable. So we have to do also supply side aggregation. We have to understand what could be the common technology modules that we can actually develop. And once we develop this module, we can actually spread it and proliferate it to many different supply side vendors. It's actually with this thought in mind that that's actually the key part of our selection process. Yeah.
All right, Chris, thank you so much for that. All right,